Alright, welcome back. Today we're going to be doing Cartesian coordinates to spherical coordinates. So the Cartesian coordinates have three values of x, y, and z. We'll have you draw something in the 3D direction, in 3D, so that if you draw a line, instead of it just going in an x and y direction, it will come up here, which will be three different things working together to get it there. Alright, next up we have spherical coordinates, which consist of rho, theta, and phi. So if we draw them in 3D again, the difference is, instead of it just being three different things working together, such as the x-coordinate being the distance from the origin to the x, the y-coordinate being the origin to the y-axis, and the z-coordinate representing the vertical distance from the origin, the difference is, I'll label this as well, we have rho, which is going to be the distance from the origin to the point, the radial distance, so we'll have it like that, and we'll imagine it like there. Our theta is going to be the xy plane from the positive x-axis, so it's going to be this angle right here. That's going to be our angle, that's going to be our theta. I'll draw this as a rho. And then we have our phi, which is the polar angle from the positive z-axis. So it's going to be the angle from the z-axis to the point. So now to go from Cartesian to spherical coordinates, in order to find rho, what we'll have to do is we'll have to find the radial distance by this formula of x squared plus y squared plus z squared. Our theta is going to be our inverse tan of y over x, and our phi is going to be our, draw that, is equal to our inverse cos of z over rho, which means that you have to find rho before you can find your phi. Alright, now we're going to do an example. So we have Cartesian coordinates of our x being 3, our y being 4, and our z being 5. And we're going to try to find our spherical coordinates. So to start, we're going to find our rho, which is going to be equal to 3 squared, because it's our x squared plus y squared plus z squared, which will give us the square root of 9 plus 16 plus 25, which is going to be equal to the square root of 50, which will approximately be 7.07, depending on which way you want to leave it. Next up, we're going to find our theta, which is going to become our inverse tan of y over x, which is going to be our 4 divided by 3, which is approximately 0.93 radians. So I'll just put rad. And finally, we're going to find our phi, which is going to be our inverse cos of z divided by r rho, which is going to be 5 divided by, and I'll just use the approximation of 7.07, which will give us approximately 0.79 radians. So instead of having 3, 4, 5 as our x, y, z, we're going to have our new spherical coordinates be 7.07, 0.93 radians, and 0.79 radians. Now we're going to go over how to go from our spherical coordinates to our Cartesian coordinates. So the first one we're going to do is how to find x. So to find x, the formula is going to be rho multiplied by sine of phi multiplied by cosine of theta. Our y is going to be rho multiplied by sine of phi multiplied by sine of theta. And finally, our z is going to be our rho multiplied by our cosine of phi. So if we use the same numbers as before with our coordinates, we're going to have 7.07, we're going to have 0.93, and we're going to have 0.79, and we're going to put that in to try to get back our Cartesian coordinates. So the first one we're going to do is we're going to have x is equal to 7.07 multiplied by sine of our phi, which is our 0.79 radians. Make sure your calculator's in radian mode when putting this in, or else you'll get the wrong answer. And we're going to multiply it by cosine of our theta, which is 0.93, which will get us 3. We're going to have our y is equal to, which will get us approximately 3, because we did round with our 0.07. We're going to have our y is equal to 7.07 multiplied by sine of 0.79 multiplied by sine of 0.93, which is going to give us approximately 4. And finally, to find our z, we're going to have it as 7.07 multiplied by cosine of our phi, which is 0.79, which will give us approximately 5.